So for section 4.3, we're going to do a little bit of review, combining it with what we now know about increasing and decreasing in concavity. We're going to talk about graphing rational functions. And we talk about a 7-step process in terms of graphing a rational function, but really this is just making sure that you have the skills necessary. You may want to go out of order when you're graphing some of these, but this is what you should be able to do with any rational function. First of all, you should want to determine whether there's symmetry. About the y-axis or the origin. Remember, this goes back to even functions are symmetrical about the y-axis. Odd functions are symmetrical about the origin. You want to be able to find the x and y intercepts. So find out where the rational function is crossing the x or y axis. You want to be able to find where you have vertical asymptotes. After we check for holes, this is going to be found by determining where the denominator is equal to 0. You also want to find your sign for f of x. Where am I changing sign, or where is it going to cross the x-axis? You want to determine the end behavior. And again, when we determine the end behavior, what we're going to be looking for is we're going to be looking for horizontal asymptotes. Remembering all of your rules for horizontal asymptotes is one thing you have to be able to find. You want to find your derivatives. Again, this will help us determine where we're going to be increasing and decreasing and concavity. And then you're going to graph, putting all these pieces that we just found together. Now, one thing you want to add up here with vertical asymptotes is you're going to also have to make sure you check for your holes. Remember, holes occur where there's a common factor in the numerator and in the denominator. So the 7-step procedure to graphing x squared plus x over 1 minus x squared, and we can check our answers with our graphing calculator. First of all, let's talk about symmetry. So if it's an even function, f of x has to be equal to f of negative x. And if this happens, we know we have symmetry with respect to the y-axis. So f of x is my original function. So to find f of negative x, all I'm going to do is I'm going to replace anywhere I see an x a negative x and simplify. So I have a negative x to the second power plus negative x, all over 1 minus negative x squared. And when I simplify this, if it gives me back to the original function, I know it's an even function. So when I square a negative, that's a positive. That's a minus x over 1 minus x squared. Notice that is not equal to my original function because I have a plus x up there. So I know it's not even. Odd functions. F of negative x, which I found up here, has to be equal to negative f of x. And remember, if this is true, we have an odd function, and that's symmetrical with respect to the origin. So to find negative f of x, remember when you have a fraction, you can have a negative sign in the numerator and have it be equivalent if you have a negative sign in the denominator. So what I'm going to do is distribute a negative sign across the numerator. So it'll give me a negative x squared minus x over 1 minus x squared. Remember, you don't distribute both top and bottom because a negative over a negative makes a positive. So I want to take my negative f of x, compare it to what I got in my even test. Notice they're not the same. But now what I also have to do is I have to take x squared plus x, distribute the negative sign across the denominator. Neither one of those are equal to what I came up with when I did my even test. So I know that none of these are equal to f of negative x. So therefore it's not an odd function. So what that tells me is I do not have any symmetry with the y-axis or with the origin. So step number 2 are my intercepts. Now before I do my intercepts, what I'm going to do is I'm going to first of all factor, and I actually am going to check for my vertical asymptotes first and my holes. Again, it doesn't matter the order in which you do these things. So first of all, when I factor, I can factor an x out of the numerator. And I have 1 minus x times 1 plus x. Notice I have a common factor in the numerator and in the denominator, so I'm going to have a whole at x equals negative 1, because I can reduce that. I'm going to have a vertical asymptote at x equals 1. So then remember, to find my whole, I'm going to have to take negative 1, plug it back into the reduced form of this particular fraction. So I end up with negative 1 over 1 minus a negative 1 is a 2. So I have a whole at negative 1 half. And I have a vertical asymptote at x equals 1. So now you can use the simplified form of my function to answer the remaining part of the questions. So then to find my intercepts, so f of x is equal to x over 1 minus x. To find my x-intercepts is where y is equal to 0. So when I set y equal to 0, that 0 is equal to x over 1 minus x. When I cross multiply, 0 times anything is 0. So I know I have an x-intercept at 0. So I have an x-intercept at 0, 0. The y-intercept. This is where x has to be equal to 0. So if I plug in 0, 0 over 1 minus 0, I have a y-intercept at 0, 0. So I've found my step 3. So now what I'm going to do is I'm going to talk about the horizontal asymptote. So I'm going to go to the next page here. So my next step is going to be the, or step 5 I should say, is my horizontal asymptote. So if I look at the reduced form of my function, f of x is equal to, what was my reduced form of the function? That was my x over 1 minus x. So this is where I look at the degree of the numerator and I compare it with the degree of the denominator. Notice they're the same. I make a ratio of my leading coefficient, so my horizontal asymptote is going to be y is equal to negative 1. My derivatives. So I'm going to have to use my quotient rule on this. So f prime is 1 times my denominator, numerator, times the derivative of the denominator, which is negative 1, all over 1 minus x squared. So I'm with negative x minus x, that's going to be 1 minus 2x, over 1 minus x to the second. So then my critical numbers are going to be where the numerator is equal to 0, so that's going to be at x equals 1/2, and then where the denominator is equal to 0, which is at 1. So then I can find where this function is going to be increasing or decreasing by doing my number line test. So less than 1/2 is 0. So if I plug in a 0, I'm going to end up with positive. So I know I'm going to be increasing until I get to 1/2. Between 1/2 and 0, I'm going to plug in a 0. That's also going to be positive, increasing. If I plug in 2, that's going to give me a negative, so I know I'm going to be decreasing. So then next thing I'm going to have is my second derivative. So again, I have to use my product rule. So again, I'm going to have so next I'm going to have to use my product rule. So the derivative of the numerator is a negative 2 times 1 minus x squared. In fact, I think this is wrong. This should be a positive 1, shouldn't it? Because I just realized this should be a negative. So f prime g minus f g prime. Yes, so this is going to be a positive x. So actually my first derivative is just going to be 1 over 1 minus x squared. That's going to change this. I just have a critical number now at 1. Sorry about that. I knew something did not look right. So if I plug in a 0, that's positive increasing. If I plug in a 2, that's positive increasing. So now when I go to find my second derivative, I can rewrite this so I don't have to use my quotient rule again. Remember, this is going to be equivalent to 1 minus x to the negative second. So I can just use my power rule. So my second derivative is going to be negative 2 times 1 minus x to the negative third times the negative 1 using my chain rule. So the second derivative is going to be equal to 2 over 1 minus x to the third. So my critical number is going to be 1. So if I plug in a 0, that's going to give me positive, so I know I'm concave up. If I plug in a 2, however, that's going to be a negative, so I'm going to be concave down, greater than 1. All right, so now let's take a look at my graph. I have a horizontal asymptote at y equals negative 1. Let's figure out what also I know. I found my x and y intercept to be at 0, 0. I found my vertical asymptote to be at x equals 1. I found I have a hole at negative 1, negative 1/2. And again, remember what I know from my derivatives is that I'm going to be increasing, and I'm going to be concave up until I hit my vertical asymptote at x equals 1. So now this goes back to number 4. I need to know what my behavior is going to be at x equals 2. So at x equals 2, if I plug 2 back into my original, that's going to give me f of 2. It's going to give me 2 over 1 minus 2, which is going to give me 2 over negative 1 or negative 2. So what I know that at 2, I'm going to have a point at negative 2. What has to happen is I have to be concave down, but I have to be increasing. So my graph is going to have to look something like this. I'm increasing but concave down. So that's what the graph looks like.